illustrative example, the stir tank heater example. And we also talked about that for you to design a proper control system, before doing anything, you need to ask the main three questions. Before I can show you the questions, can you kindly write them in the chat just quickly? Let me see if you remember the main three questions that we need to ask before starting any control system design. Just flood my chat. I'd like to see as much as you can writing. I'm not going to comment because I would like everyone to participate. So please write them down so that you keep them in mind. Okay, so all your answers are correct. Those are the three questions, three basic questions that must be asked before you commence in any attempt of designing a control system. Again, this is a 400 level which involved design. It involves design. So you need to know how to design, and that's what we will be doing throughout the whole course. So the three questions are what, how, and what could prevent me from achieving my task. In other terms, those are three types of variables that we must make sure we know them before proceeding and designing the control system. The controlled variables, which are the variables or the output variables that we seek to keep under control, because if we do that, the system will perform task correctly. If we don't do that, the system will not perform its tasks. The manipulated variable, usually it is very difficult to control the controlled variable directly. For example, the temperature, you cannot control the temperature directly, unlike the flow rate, which can be controlled directly by reducing an opening of a valve or by increasing an opening of a valve. The temperature should be controlled using other variables, and those variables are the manipulated variables, those the variables that I change in order to achieve a change in the control variables. Usually, in any given system, sometimes one variable can be influenced by more than one variable. So if I choose one of them to control my variable, then the rest will be considered as disturbances or disturbance variables. And sometimes they are referred to as load. And these are represent the input variables that can cause the controlled variable to deviate from their respective set points. Again, when we talk about input and output, we don't mean the system input parameters or the system input flow rates and the system output flow rates. They could be, yes, sometimes output and input variables, but when we talk about input and output, it is in terms of the model of the differential equation that represent the system, which identify the output variable as the variables to the left-hand side of the equal sign and the input variable as the variables to the right-hand side of the equal sign. Please notice the difference because there is a mix-up that happens. Sometimes people think that when we say output or input, we mean the inlet flow rates and the outlet flow rate? Yes, sometimes the outlet flow rate is an output variable and the inlet flow rate is an input variable, but this is not always. For example, in the case of the level tank system, the basic level tank system, the output variable is the height, the input and the input variables are the inlet flow rate and the outlet flow rate. Okay, so please know the difference between the two. Now move into another example, which is slightly more complicated. and require more analysis. And then again, we start by asking the same question. This is a heat exchanger. And as you can see here, we are using steam, hot steam, usually. And this is very important fact that you need to remember. In any industry, in any process that utilizes steam, there are three types of steam. There is the low pressure steam, there is the high pressure steam, and there is the medium pressure steam. And they are referred to as LP, low pressure steam, MP, medium pressure steam, and HP, high pressure steam. The medium and high pressure steam are superheated steams. They are in superheated condition. The low pressure steam are in saturated condition. Okay. Usually for heating purposes, they use only saturated steam, not superheated steam. Do you know why? They never, ever, ever, ever use superheated or medium pressure, high pressure steam and medium pressure steam, which is superheated in heating or cool, or on heating basically. Why? Anybody can give us an idea?
Maybe because it is high pressure, so it requires any more thickness of the material construction.
Mm, good logic thinking, but no, this is not the reason. Good deduction. You are deciding that maybe it's related to the type of steam, but this is not. Usually, when they design the material, it doesn't matter if you design the material. If you want to use high pressure steam, you can use high pressure steam. Material is not an abstraction. There is something else. Okay,
Is it
I don't want to give you. Yes.
because of the flow rate? يعني it will be high if we
Mm,
increase the pressure.
Not really. Not really. Again, good detection, good judgment, but it's not the correct answer. Now, what I will do, I don't want to give you the direct answer, so I would like you to go and search for an answer. Put that question as a challenge question for you. Why medium and high pressure steam, or basically superheated steam? Okay, Fatima, thank you very much, Fatima. Could you explain a little bit further? Could you explain what you said? What you said is correct. Superheated steam is much less effective at heat transfer, but how? Do you know why, or do you have any idea on why medium pressure steam and high pressure steam are not very effective? Okay, I'll leave it with you. I think it's better that you search, and just remind me next time to, if I don't answer, because I might forget, if I don't answer, to answer this question. Why superheated steam is not used as a heating medium in industry? Okay, just remind me to do that next time if I don't do it. Okay, but for, or in fact, let me just explain it to you. No problem. Let me just explain it to you. Okay, rather than keeping you anxious. Okay, so let me share my, just give me a minute to share my whiteboard. Just give me a second. I would like to share my whiteboard. Sorry about that. It's taking more than I expected. Okay. Okay, so let me share my whiteboard. Do you see my whiteboard now? Yes?
Not yet.
Not yet? What about now?
Yes.
Okay.
Yes.
Okay, okay. So let us explain the concept. Now, if you remember in thermodynamics, how saturated steam uh, 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 equip any liquid by the temperature, it works in a region which is characterized by constant temperature, where we are working in exchanging the latent heat of vaporization or the latent heat of condensation between the two, okay, the two mediums. So basically, what happens? It's like when you are boiling water, when you have a kettle or a vessel, and you are boiling water, and you have a thermometer that measures the temperature will remain constant for some time until the latent heat of vaporization has been gained by the whole solution. Then the vapor starts forming and the temperature will start increasing. So in saturated state, the saturated steam will not, the temperature between the inlet steam and the outlet steam will be more or less constant. There is not big range of, there is no change in temperature. For example, if I have the heat exchanger, if I have the heat exchanger like this, okay, this is the steam in and this is the steam out. So if it enters at 100 degree, if it is saturated steam, it will exit at 100 degree, but not as a steam, as water, or they call it condensate. As a condensed water, this is steam, saturated steam. Okay, so the temperature is still constant. So from where the energy that has been equipped into this process stream came, it came from lambda. So basically, what do is we, because it is in saturated state, the energy exchange is the latent heat of vaporization, which is a significant amount of energy. Now, if you want to do it in superheated steam, the difference that you need to achieve in order to equip this process stream with the same amount of energy could be, so for example, if it is superheated steam, then you have to go for, say, from 130 into 100 or into 90 in superheated conditions. Okay, so that is around 40 degrees Celsius. That is a big range. In this case, we don't need a big difference of energy. All what we need to do is just equip it with lambda. This is number one. Number two, the superheated steam is categorized as a poor energy conductor. It acts like air. It's more of an insulator rather than an energy conductor. So to achieve the same amount of heat transfer, you would like higher flow rate, higher energy levels. So it's not efficient to use superheated steam. It's like when I say for you, which is if I want, for example, to go into a short distance, say between, for example, Isa Town and Rafah, okay, is it better to take 8-cylinder car or is it better to take 4-cylinder car? Of course, the most efficient solution is to take 4-cylinder car. Why? Because I'll be saving petrol. It will still be, especially during the rush timing, it will be the same. I cannot utilize the speed. The speed does not matter here because there will be lots of cars. So the distance will always be 15 minutes, irrespective whether I have an 8-cylinder, 12-cylinder car, or 4-cylinder car, because I will always be going at the same speed. However, I'll be putting more petrol, more money into the 8 or 12-cylinder car than the 4-cylinder car. Same principle applies. If you use superheated steam, you will be putting more energy, you will be increasing the temperature to a very high temperature in order to achieve the same amount of heating that can be achieved using saturated steam. So of course, it is saturated steam that are much preferred. So it comes all to the efficiency. Saturated steam is more efficient, more good as a heat conduction, and also it contains the energy, and I don't need to kind of increase the temperature into a very high level to get the same amount of heating. So I hope this explains the idea for you, but that's basically why we don't use superheated steam as a medium for heating. Does this make sense for you? Do you understand what I'm saying?
Yes, doctor, but I have a question, doctor.
Sure, sure.
يعني, why not يعني, to use this high pressure steam or medium pressure steam at saturation condition? يعني, what prevents us
It
from
will.
doing this?
It won't be in saturation condition. When we say high pressure steam, it means that very high temperature and very high pressure, which means that it's not in saturation condition. Okay, medium pressure and high pressure is not in saturation condition. You know that for each temperature there is a saturation pressure, and for each pressure there is a saturation temperature. They exist together. So if the temperature is higher than the saturation, this is no longer a saturated steam. It's a superheated steam. If also the temperature of the water, okay, is and the pressure are higher than the saturation, it is sometimes called either super cooled water, or it has different names. But when it comes to saturation, they exist in certain temperature, have certain pressure. Like for example, at 1 atmospheric pressure, the temperature, saturation temperature is 100 degrees Celsius. As the pressure increases, the saturation temperature increases. As the pressure decreases, the saturation temperature decreases. So they come together, they come in pair. ما تقدر تاخذ واحد وتخلي الثاني. You cannot take temperature and say, okay, I will produce saturated steam at 130 degrees Celsius for any pressure. No. At 130 degrees Celsius, there is a specific pressure setting to reach the saturation condition. So saturation steam is governed by certain pressure and temperature coordinates, couple, pairs. You cannot separate them. Does this make sense?
Yes, doctor.
Well,
Thank you.
still, if you are still confused, please.
الصراحة يا دكتور, there's a point يعني regarding يعني at this مثلا high pressure steam.
Yes.
It is high pressure, so why not to maintain at higher temperature so we get يعني saturation condition?
Then
What
then
prevents us?
you are putting more money. It's like you need to transfer items between two different places. Would you use a Ferrari or would you use a pickup?
Backup.
Would you hire a Ferrari to take some luggage between two places, or would you hire a pickup? Unless of course you have
Backup is
to,
in.
unless you have too much money, you don't know what to do with it, huh? And you want to show off. If you want to show off in your plant, if you want to go in the media and say, well, I have too much wealth, and in fact, I am operating my plant. I am heating my plant at a saturated steam, but very high elevated temperature. Then you can do that. But as we say, you have to put more money to increase, for example, the saturated steam. The steam quality, it has a price, and I don't know if they have taught you this in design or still not, but for each degree Celsius, for each 1 atmospheric or zero point 0.1 atmospheric pressure, you are paying more money. So if you want to produce saturated steam at say 130 degrees Celsius, corresponding to a certain temperature, that will cost you money more than producing at 1 atmosphere and 100 degrees Celsius. So the higher the steam quality, the higher the cost, and you are trying to maintain a very economical plant. So you would like to operate at a lower cost. Okay. So again, to answer your question, why we don't operate at a saturation level with very high temperature, if it is necessary, I will be obligated. Okay. For example, now having said that, okay, if they use saturated steam for the purposes of heating, then what's the use for medium pressure and high pressure steam? Well, there are other utilization for them. For example, one example for them, sometimes they use the steam power to rotate compressors and turbines in industry. Sometimes it is much economical for them to use steam power to operate compressors rather than electricity, because electricity costs higher money for them. So pressure, medium pressure and high pressure are used to move things. They use the kinetic energy in that, stored in that pressure, to rotate compressors, large pumps, large machinery, produce even power using steam turbines. Okay, but for heating purposes, it is always saturated steam, and you would prefer to operate at a very low pressure and temperature at atmospheric conditions. This is much more preferable because this means that you are putting less money in producing that kind of steam. Ah, safe. Sense?
Yes,
Makes
doctor.
sense? Doesn't make
It is.
sense.
لا لا, yes, it's clear now. But
Okay.
and what if my fluid, process fluid that I want to heat is above the low pressure steam temperature? يعني how?
Then yes, then you have to operate at a higher. Again, this will cost you money, and usually they don't, for this kind of heating, they don't use heat exchanger. Most probably, they use what is
So-called
known.
heaters?
Yes, they use
Uh,
burners. Okay, because it will be much efficient. Again, burners operate at airflow, and again, air is a poor conductor, but that's the only way you are using it, because it will be cheaper to burn fuel because you have air in abundance. It's all over you in the atmosphere. So it's better to bring air in, charge it with energy, and use it to heat fluid to a degrees above, say 100, 150, or 200 degrees. Okay.
yeah. Yeah, thank you, doctor, for the elaboration.
Okay. Let's go back then to our sorry, uh, presentation. Okay. Just again, I'm using two devices, and that is causing me to kind get a little bit confused. Okay, excuse me about that, but just give me 1 second to skip. Okay, so let us go back to the presentation and continue from there. Okay, so we said that we talked about the first example. We are talking now about the second example. So based on that, I have steam here. I have steam coming, saturated steam. There is, as you can see, there is a control valve controlling the steam flow rate. And this is my process stream, the process stream I want to heat. And then, as we said, usually I will be extracting the output of the steam as a hot liquid, as a condensate. They call it liquid condensate. Usually, again, this is also something that you need to know, that the steam cycle is a closed cycle. What does closed cycle mean? This steam is converted into condensate. It goes back to a plant where will be transformed again to saturated steam through boiling, and then return back. Why? Because the quality of water I use in a steam cycle is of a high standard than the normal water or the normal potable water I use everywhere else. It is it has been treated in such a way to make the system immune against corrosion. So, for example, they take air out of that water. They eliminate oxygen from it. They put some chemical additives to make that water. It's like the coolant of your car. You add antifreezing agent, which is ethylene glycol, that greenish chemical into your cooling cycle. So that's a kind of treated water because you want to prevent this water from freezing during lower temperature in winter. So the same thing happens to the steam cycle. They have to treat it. So now, according to this schematic diagram, what do I want to control? Obviously, my aim in this illustration is to maintain the temperature T, or T as a function of time, in at a certain level. And let's introduce a new concept here, or a new language, or a new nomenclature. We call it the desired level. We call it set point. Set point. Set means sitting at, and a point. It's a point. It's a level where you want to maintain your temperature at, and you don't want to change from that. And why is that? Because that level gives you the maximum operability, or the maximum benefit. Based on your design calculation, if you operate at that level, you will get the maximum benefit. Eventually, by building a plant, you want to get money. You want to manufacture something and sell it for people. And to do that, and to operate at a preferable range, you have to operate at a certain level. It's like when you open a project, say a cold store, for example, Barrada, you do a calculation, you do a feasibility study, and you say, okay, if I sell items in a daily basis at 50 dinars per day, if I sell at 50 dinars, I am breaking even, which means that I am paying all my bills, but I'm not getting money. Anything above 50 is revenue for me. It's income for me. So here you say, okay, I want to operate at a certain set point. Anything above this set point sometimes is not recommended. Anything below that set point is not recommended, because above you might be losing money, below you might be losing money. You want to operate at exactly that limit, at exactly that temperature. So this, we call it set point. So we want to maintain this at set point. So what we want to control? We want to control the exit temperature of the process stream. And also, we want to prevent any disturbances. What kind of disturbances here? Can you give me an idea of what to expect? What are the variables? Of course, if I want to control the temperature here, the obvious choice is to change the flow rate of steam. Because eventually I'll be changing the exit temperature. That's the obvious choice, and it's a common sense choice. But what are the other variables that might prevent me from doing this task?
The
You
inlet
may
temperature and flow rate of the process fluid.
inlet temperature and flow rate. Any other thing you could think of? Any other people? Come on, guys. Participate. Make it two-way. Don't just limit yourself to listening. Think of other variables. Yeah, adjusting control valve will do the magic of controlling the exit temperature, adjusting the control valve of steam. Now, Safe said that the inlet temperature is a disturbance T, this temperature here. This is a disturbance, and also the flow rate. Correct, Saif? That's what you said?
Yes.
Okay. What else?
Q.
Which Q? And by Q, what do you mean? Q
I mean the
as an energy flow rate or Q as a flow rate? Capital
energy.
Q or small q?
Capital.
Capital Q, energy. Yes?
Yes.
Yeah. So energy basically here is supplied to the system in terms of steam flow rate. Energy Q is supplied. So it's basically M, mass of steam, times Cp, heat capacity of steam, times delta T, okay, or because we are operating at constant temperature, because we are operating at constant temperature here, the temperature does not change. It will be UA delta T, or it could be also as a function of lambda. Because you are operating at a constant temperature, the temperature does not change. The inlet and the exit temperature are constant. You are only equipping the system, the heat, the energy, the heat of vaporization. Then Q will be a function of lambda, heat of vaporization, and it depends on the unit of lambda. So basically, knowing that, changing the parameter of the steam, for example, the temperature and the pressure of steam, could also be a disturbance. Could also be a disturbance. Okay, so this is a prerequisite step by when you are doing any control design. Just put the system in front of your face and start asking questions just to make sure that you satisfy all the necessary conditions before jumping into conclusion. Okay, let's move a little bit. Now, we have another control terminology. We, as you have seen now, in the previous, in this slide, we talked about set point and we talked about disturbances. And we said that set point means the level at which I want to operate my system at so that I get profit. There is also disturbances which interfere with me doing that task. Okay. There is sometimes after a, say, for example, I go and I do some analysis. And then an engineer tell me, okay, why you are operating at 100 degrees Celsius? I say, when I did my design, I discovered that this temperature gives me the maximum profit. Then this engineer replies back and say, but I did further analysis and I discovered that if we lower the temperature 5 degrees, we could even get more saving and still maintain the output as it is. So can we operate at 95 degree? I take this information, I go, I do a calculation, and I discover that what this engineer is saying is correct. So what I will do now, I will lower my operating set point. Instead of operating at 100 degrees Celsius, I will operate at 95 because I will be saving money. I am operating at a lower temperature. Number two, I still maintain the profit, but at a lower cost. So this means more money for me. So in this case, this means that once you determine a set point, it doesn't mean that you will stick to it. Maybe later at the lifetime of your plant, you want to lower the set point. You want to change the set point. Okay. Let's take another example. Sometimes, no, I say, okay, no. I don't want to change my set point. I want to keep my set point at 100 degrees Celsius because this is the best thing I've calculated. There is no way other point can give me better results. And then the engineer, the same engineer comes, هاي engineer نحيس شوي. The same engineers comes and say, well, we would like to keep the set point, but there are lots of interferences. The inlet temperature keep changing because of the atmospheric condition. The steam temperature and pressure, the guys at the steam plant are not very good, and they keep changing the settings for us. The flow rate of the inlet process stream keep changing, so we cannot maintain it at 100 degrees Celsius. There are lots of disturbances. Okay, because of those two examples, sometimes I want to change the set point. Sometimes I want to protect my system against disturbances. I have two modes of control. The first mode is called set point tracking. The second mode is called load rejection or load change or disturbance rejection. Two mode of controls. In the first mode, I will change the set point and the plant will follow. In the second mode, I will keep the set point constant, but I will protect my system against any interferences from any other variables within that system. Now, I will tell you a story here, okay, that explains why we have two different modes. When people started, now, most of the inventions, معظم المخترعات اللي احنا ننعم فيها اليوم, most of the inventions that we are using now, when you trace its origin, most of it are related to military applications. During wars, people tend to be more creative because they want to become much better than their opponent so that they can win the war. So lots of inventions come to reality as a result of military application. Let me give you a specific example. The internet, it was a military application, and then it became civilian. The GPS, the GPS that you use in Google Maps, this is a military application. Process control, in its origin, referred to as a military application. It started in the early 40s when the armies in conflict in the Second World War wanted a missile guiding system that can narrow down the hit range into a few meters, a few hundred of meters, so that the errors are reduced. If you want, for example, to hit headquarter, تضرب قيادة من قيادات الجيوش, and you want to increase the effect so that you get an advantage, you don't want this missile to get stray from its target and hit somebody else, or because the enemy now is alerted, they will evacuate that center and you lose your opportunity. So they started working on the control system for guiding the missile. And from there, the control engineering has been born, and we started using that in engineering application. That typical example, guiding the missile into a target, is a set point change. You have a set point, you have a geographical location, and you want the missile to hit that geographical location every time. So you have a set point, you have a target, and you want to always be or follow that target. And this target might change. For example, today I will be hitting a headquarter, tomorrow I will be hitting a boat or a destroyer in the sea. Next time I will be hitting a bunker contains airplanes because I want to disable the enemy of launching an airstrike, and so on and so forth. So set point changes and the system follows set point. Now, after the World War II, the control system did not end with the war. when those people who were serving in the war returned back to their countries, they started building their countries. They started building uh, 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 industries. They started building plants, and they borrow the concept of control to apply it into their plants. But now it is slightly different. I don't usually change the set point in a plant. In process engineering, once you discovered the ingredient that gives you the best uh, production, you don't tend to go around and change it often because it creates disturbance in the whole plant. So what do you do? Well, I fix it and I try to protect it. So the second concept, which is the load change or the disturbance rejection, has been born. And what does this concept do? You say, okay, I want 100 degrees Celsius. What are the disturbances? Disturbances is flow rate. Okay, please protect my system against flow rate changes. So you are monitoring flow rate changes and you are adjusting the system accordingly in order to protect your system. So those are two different concepts. Usually in process engineering, we always work according to the second concept, but sometimes we also change the set points and try to, kind of give the plant much more flexibility. Okay, just before conclusion, let me go back to the first slide, which tells us why do we need to do process control? Why do we need to do process control? Now, based on the stories I told you and the analogy I told you, a control system is required to compensate for influence of external disturbances whenever things change. And believe me, things will change. Temperature in winter is different than temperature in summer. So for sure, it will affect your system. A composition might change because you have, for example, natural gas composition can change between different seasons because you have solubility of certain agent, chemical agent increases from season to season. So things do change and you want to protect your system against these changes. Number two, the most important task and the very, very, very emphasized task is process safety. You don't want to expose your personnel, your people who are working in that plant and your equipment to hazardous situation, explosions, for example, because you are operating at a very hazardous level. So you want your control system to care of safety whenever there is temperature increase in a certain system above the allowable limit. The control system will jump in and takes safety precautions, like, for example, shutdowning that system and not allowing it to develop more high temperature. Also, sometimes, even if you operate at safe conditions, your process is not optimized. For example, you are spending too much money in your resources and you want to reduce your consumption of resources, electricity, steam, chemicals. You want to reduce that. So control will always allow you to optimize your plant, like maintain the optimum amount of usage of utilities, power and steam, of chemicals. You will just get the required amount of chemicals that will give you whatever you are desired. And then finally, to make sure that when you produce something, you always produce it in the same specific or specification written on the back of that product. For example, if you are in a paint factory, you don't want to produce red color in different proportions. So when the people take them and they start painting their houses and their rooms, there is always different uh, 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 colors of the same. You have two containers having the same serial number or the same product name, but they give you two different colors. People will never buy your material. So you have to maintain the specification. If you say, I am producing methanol at 95% purity, it shouldn't be 94. It shouldn't be 92 because people will get angry with you. They say you are selling us less product specification. And of course, it shouldn't be 98. Why? Because being 98, you could charge it at a higher rate. And if you say 95 and it is 98, of course, the customer will be happy, but your boss will not be happy because you are losing money. You could sell this at a higher price. So these are the kind of things we expect to when we talk about why do we need control. We had two examples and we identified three terminologies: controlled variables, manipulated variables, disturbances. And then we also identified the two modes of control: the set point change and the load change, or the set point tracking and the disturbance rejection. Next time, we will talk about why do we need automatic control, and also we will have some more examples. Do you have any questions? We still have 1 minute if you have any questions that you want to share. Again, you might use the Teams for asking questions, but please use the @ sign, or you can write to me on private messaging. Until next time, I wish that you stay safe. Please keep updating yourself, read the material I upload into the file section, and keep going with me. This is the only way that you'll get straight A in this course, and it's not a mission impossible. It's possible, it's just need dedication. Thank you very much. I shall see you next time.